our pieces are moving. We can even switch turns, so play white then black. We can move all of the different pieces across the board. There are a couple of problems, of course, as you know, that our pieces can move on top of the others. For example, like this, which is not the behavior we're expecting, and also this way. But something that also happens, which is even weirder, I don't know if you noticed or if you tried out, if I select a knight, I can only go in these three squares, right? If I click on this square, nothing happens because you cannot go there, which is fine. If I click on the knight, I just unselect it, and now I can select a new piece normally. But if I select the knight, and then I select any other white piece, it teleports on its place. Why this happens? Here on our boards, we're saying that you can select if it's a valid move or if it's a piece of the same color. And this is very important because we are allowed to select any piece of this color, of the player's color, even if it's not a valid move. And when this happens, we're going to say here, select this square. We could go these two ways. We could remove this from here or improve this logic and say that you can only select if it's a valid move and or is the player color turn, but only if it's the color turn and there is not selected already. But I think this will add a bit too much logic. So I think it's just better for in the select square to verify before we make this move if this is a valid move. Adding this logic here, then if it's a selected square, if they already have a selected square, and then we're going to add is valid move, setting of course this square, we can check it out. If not, you just select this new square, because that's the idea. Like, let me refresh here. I'm going to say, okay, this pawn moved here. Now I select this knight. If I select and I add this knight and I click here, I want to select this pawn, right? So it's the logic we have here as of now. If it's a selected square and it's a valid move, then we try to move. If not, we just select this new piece. Simple as that. Simple fix, but could save us a lot of problems in the future if we didn't see it as of now. Now it's time for us to fix the movement of the pieces so they don't jump over the others and of course don't capture our own color. So there is three important information here. First, our piece cannot move into another square of where there is a piece of the same color as the one I selected. So a white piece cannot never enter the space of another white piece. Second, I cannot jump over the pieces, except if I'm a knight. The knight has a specific, let me refresh here. The knight has a specific behavior, which is jumping over the other pieces. It's very unique to it. And lastly, when I need to be able to capture the first piece on my way, the first piece of the opposite color on my way. So I cannot capture the rook, but I could capture here this pawn if this pawn was not on the way. Let's suppose the rook was here. Now this pawn could technically be captured. Okay. And also have some uniqueness about the way the pawn captures, that captures to the diagonal. We're going to deal with that. But for now, what we want to focus is we cannot capture our own pieces. So I cannot go here to here. I cannot jump over my pieces unless I'm a knight. And I can only capture the first piece of the other color that I find on my way. So all of these things I did, they're not valid. We're going to fix them. Let's start by the rook. I'm going to the move service. And the move service, we have here the rook, adding all the valid movements for all the columns in this row and all the rows in this column. This is what we have for the rook and, of course, partially also for the queen. We need to fix this in order to, for all the columns in this row, respecting the rules we just said, cannot jump over pieces, cannot capture our own pieces, and can only capture a piece of the opposite color. Let's then, for now, just break this down into fours. I'm going to keep it like this. Okay, so we have two fours. It's stupid, I know, the way it looks right now, but we're going to work inside each of these because we'll need to treat the columns of this row and the rows of this column each on its own, so we can validate for the pieces on the way. And these pieces are on the board. So to check on them, we need to receive here the board, which is of type board model. Let's import it. And of course, in our board, we need to send it to this function. So I'm going to send here the board, add also as dependency here, the array of dependencies. And our move service can now make use of the state of the board in order to validate the moves. Let's first find this position, find this target square, so where we want to move, which is the board squares find. I'm going to say here item dot coordinates row equals to the row, and item dot coordinates dot column equals to I, because we're looking here, it's the target square, it's not the current square, it's a target square. Now, in this square, we're going to check if target square has a piece. What we're going to do, we're going to check if this piece is of the same color as ours. So if target square piece color is the same as our current square dot piece dot color. How this will work? Let me just add here, and maybe also, no, this is fine. Okay, let's add this valid move here inside and check it out, this logic that we have now. We search for the square that we want to go to and check, is there a piece on this square? If there is a piece, let's check the color. If the color is the same, we don't want to be able to move to this. So this is not a valid move. We don't want to move on top of our pieces. But if the color is different, we do want to be able to capture it. Well, there is to move on top of it. So this is a valid move. But after we find the first piece of the opposite color, we need to break. So we don't continue looking forward into this here, into this row, all the columns into this row. We don't need to keep looking for it because we already found the last position that we can go to, which is the first adversary, the first enemy piece. And technically, if it's the same piece color, it's this my piece of my own pieces, we don't add the valid move because we cannot go to it. We just need to break. From here, everything is blocked. You don't move anymore. Of course, this if else is completely stupid. So what we're going to do is to move the break out of it. And this logic covers two of our three requirements. It covers the having a piece. I cannot jump over it. I cannot move into my own pieces. I can capture the other pieces, but we still have a problem of we cannot move. We're not allowing the movement through an own empty square. So now we're going to say that if there is not a piece there, we just add this movement. Let's check it out how this plays. I'm here with white. If I put the knight here, now technically if I select this rook, let me move one black piece. Let's select this rook, I could move here, but here we didn't change anything, so we didn't change any of the columns, and I should be able to move here. Let's check the code and see what's going on. For the rook, we're starting to check on the position 0. And what is position in the 0 in the current row? What is position the column 0 of the current row? Isn't it the rook itself? It's exactly that, the problem. So here, what we need to do is actually, instead of starting on 0, we need to start on row +1. This is what we need to do. And then we go up to 8. So we start the position from this one. Otherwise, we'd be considering that we're trying to move into our own position again, and then we would be blocking ourselves, which is not the case. If we apply the same logic, or very similar, of course, to the column, let's add it here, column, move, no, let me move within row, add it here, so move within row, and this one move within column, just to make sure, really clear what we're talking about. And now we're going to say here, the row is 1, it's I, and column remains the same. Also going to update it here, the logic is the same, but checking I starting with column plus 1 until 8, and here we check column being column, and row being I, just inverting from column to row, row to column. That's what we're going to do here on this other side. And now you see that the rook cannot move over our pawn. If I select our pawn, I'm going to move it here, just for the sake of it, move that one. And now our rook can move here. Let's suppose, let's move our rook a tiny bit so we can see it in action. You see that there is still some problems here. We're going to get to there in a moment. I'm going to move it here and now here. And you see that this rook can capture this piece. But what is going on that our rook is moving so weirdly? Let's take out this knight, put it back, put this here, and now here everything is fine. Okay, but why is the rook now jumping over the knight and just coming back one square of something doesn't look right. Let's go back to our code, check it out, what could be wrong. Let's see the if first, so if target where there's a piece and then there is the piece color different, we're going to add it, if not just break, and even if we break in the end, else we add it anyway. So this if seems correct to me, the find also seems fine, there's nothing much to go wrong here. The for is wrong. Here is a column and here is a row. This happens because we're moving the columns within the row. So we need to check for the current column, nor the current row. That was my problem, my mistake. And now I see that we can go only up to the knight, but we cannot go back. This happens because we only did the for going up. So starting from this, we're moving up the board. So to the right, top, up, and to the right. What we need to do here is to invert this logic and say, while I is column -1 and greater equal to 0, I minus minus. The same way for here. Row -1, I greater equals to 0, I minus minus. There we have it. And now our rook can move to the correct positions, both up and down, left and right. Let's move it a bit, check out how it works. If I can take this pawn here, it's fine. Now I can go left, can go up to the knight, can go down, can get here to this pawn. Let's move the king. Yeah, that's fine. I can capture the king, which is definitely not allowed, but this is a problem for later on. We're going to step by step in all this gaming logic and just move it here. That is fine. Okay, the movement is good. The code, definitely not. Let's check it out how we can improve this code and remove all this repetition and this looks awful. First thing I want to do is to create a new service. So I'm going to call here the coordinate service. Yes. And I'm going to export a const. The function is same coordinate. Receiving coordinate 1, so coordinate model, and also a coordinate 2, which is also coordinate model, returning a boolean. Inside of here, we're just going to return coordinate 1 dot row equals coordinate 2 dot row, and oh, there's a lot of equals here. Coordinate 1 dot column equals coordinate 2 dot column. So we are going to make this logic in a central place to not repeat these same checks all over again and again and again and again. Now, in the coordinate service, we could replace this already by this, what we just created, but I want to do it better. I want to go for our board model, and create a function here, which is get square on coordinate, receiving a coordinate and returning a square model, or undefined, or no. Let's go for undefined for now. Here we're going to return our this dot squares dot find what is same coordinate, we import it, item dot coordinate with coordinate. Just going to return that. If it doesn't find it will return undefined. That's not a problem for me. In our move service, all of this can be replaced by board.get square on coordinate. Let's go here, create const target coordinate, like so. This would be of type coordinate model, just to make sure. And now guide square on this coordinate. This is our target square. Can remove this and add the push for the target coordinate. And here as well. So this will be our first improvement. Okay, I'm going to add the same logic here. Of course, we're going to remove all the repeated code. Don't worry, don't worry. But I like to refactor it, make sure that they are all the same, and then to be much easier than to extract all of them in one piece. Here, it will be very similar. I just need to update the coordinate because it's not changing. The row is changing, not changing the columns, changing the row. This will change as well. And now here we have target coordinate to be this one as well. And I can replace all of this here as well. So now with this is more refactored. We have even a couple of more lines, but we can see that all of these fours, the only difference between the four of them, even actually just 2 for 2, is this target coordinate. All the rest of the logic is the same. This logic here is the same as this one, and as this one. Let's then extract maybe all of this into a separate function and then call this function in all of these four fours. That's fine. But we do have a break. And how then we can transform all of this in a separate function, given that this break needs to be inside of this for? A simple way of dealing with this is creating a boolean that will trigger this break. Let's create a function here, const check move, or check specific move, check valid move. Let's call it like this. We don't know exactly what will be required, what it will return, so I'm going to let it like this, empty as of now, and copy paste all this logic that we said is the repeated part of the logic inside this function. Okay, so we have target square, target coordinate, and a lot of stuff. Let's see what we need to receive as a parameter. First one I see here is the board. Stuff board model. We also need this square, or maybe not the square, but which piece color there is there, but for now let's just send this square. And also the target coordinate, which should be of coordinate model. This is what we need. But we still have the problems with the valid moves and the break. I'm going to fix that by creating an interface called moveCheck, which will have inside of it the move to be a coordinate model, so possible move, and a should break. You can call this another thing if you'd like to, any other name, as long as you understand what's going on. And return this move check here as this function. Now, whenever it reaches this should break, I'm going to say that this should break will become true. So const move check Let me give this here, let's say move. It's going to be target coordinate, like this, and should break is false, up, like this, because we want to move to that coordinate, and we're checking if should break. Now the move check, here I'm going to say should break equals true. And instead of adding valid moves dot push target coordinate, we're just going to remove all of this. Move check dot move is target coordinate here as well. And now we return the move check. I know there's some repetition. We're not going to need to do all of that because we're repeating what already set. Don't worry. Go step by step, step by step. What's problematic here? Piece is possibly no. So let's just check it. And now we're going to receive here const a move, possible move. Check this, sending down the line our probable coordinates. We want to check if this move here is valid, but we also need to send the board and the square. And with that, we're going to check if possible move dot move, possible, not possible move, valid moves here, the array valid moves dot push, our possible move dot move. And if should break, possible move dot should break, we're going to break our for. Okay, this is our first idea of implementation. There are some errors here though, because move could potentially be null. And it's what we're going to start with. Start with null. Specify here that move check is of type move check. These TypeScript errors go away. And now we make sure that this move is only set whenever it should, because before it was also setting even if this should break was true here, like it was always check. Okay, this seems fine. This is the same logic we had before, but now separated in a different function. With this smaller piece of code that we have now, if we just remove these brackets, we have even less code, but I'm going to let it as of now. Okay, repeat all of this to this for, and something very similar to this one. Let's just paste this here. And now this to here. So this is how I like to work when I'm refactoring code and making sure that everything is working fine. I refactor bit by bit, I go copy pasting, and I see that, okay, what still can be improved, what can be removed, because there is still now plenty of code that is still the same. Although little by little, we are moving away from this super big code repetition to smaller pieces of code. So now the question is, can we make these fors that are repeating over and over, which is slightly different, and bring them in a separate function to reuse all this logic instead of having 4, 4, 4, 4 here, because we're going to be able to need to do the same for the bishop, for example. And although the knight and the king will be slightly easier, we need to reuse what we can from here also for the other pieces. So let's bring all of this inside a separate function, which I'll call get valid moves for row and column. Big name, but I think it's fair. And inside of this, I'm going to put our for, returning an array of the move check coordinate models here. Not move check, coordinate models. These coordinate models, the result of it, I'm going to insert into the valid moves that I already have here. So it would be something around this. Valid moves dot push. Then I'm going to say get valid moves for row and column, sending something there, and this is structuring it inside. Simple as that. We still need to check though the parameters we're going to send. Let's create here these valid moves, which will be an array of coordinate model. Simple like this. And now return the valid moves. What do these for need to work? It needs a starting point, an ending point, and a direction, because this can be plus plus, this can be minus minus. And here, the tricky part is when to check for smaller than or when to check for greater than. So let's create up some props that will receive this information. For example, the start pose should be a number, end pose should also be a number, and the increment also a number, all the three of them. So start position, end position, and the increment. To not add all of this and much more parameters here, I'm going to create an interface, which I'm going to call row column valid move check, and add this inside. Now, instead of receiving then parameter after parameter, I'm going to receive one object with all this information. I'm going to add it here. I'm going to destruct directly, whoops, like so, and have here start pose, end pose, and increment. This start pose, as we saw, is this one. The end pose, it's this one, in the end position, and the increment, we'll just change it slightly to be like so. This is the idea we have. But as I mentioned, the tricky part here is the smaller or greater than. So what we can do is we're going to check if the increment is bigger or equal, bigger than 0. We're going to check for this one. If not, we're going to check the other way around. So if the increment is bigger than 0, we're checking until it gets to a certain point, like it's smaller than, so because it's increasing. If not, it means that the increment will be smaller, to be the -1, and then we need to check until when it needs to go decreasing. To make sure that we are using the same logic, instead of using smaller than here, I'm going to smaller and equals, okay? Like we're using here, greater than equals. This will change slightly how we do it here, but the idea will be the same. We're just going to change the number from 8 to 7. So let's go ahead and do this change here, so we don't forget. And as you know, this will remain exactly the same. And I will change also here for the bishop. Okay, gives a 7. Okay. Let's add the parameters to our function that we have here, saying that the start position it will be column +1. The end position will be 7. And the increment will be 1. Please have here plus plus. This is what we need for now, but if we look into our function here, we're still missing a couple of information, the board and the square mainly. So let's add here as well as parameter, board model, and square to be square model. Coming back to where we call it, I'm going to send the board and the square. Now what we miss is the row and the column, but here it's interesting as the row is from the square and the column as well, but the column here is changing and sometimes is the row changing. So how can we deal with both of these informations? We're going to add here to our props, to our parameters, update row being a boolean, and update column also being a boolean. And what we're going to do is to use these two constants, these two variables. Let me grab here the update column as well, to understand which one we should set the value to. Now, these two, let me remove. I'm going to put here const, just coordinates, maybe like new coordinate to be row and column. And I'm going to check if update column new coordinates dot column, just an idea. We're going to refactor this in a second to be equals to I. And if update row, we're going to do the same. New coordinate dot row equals I. Then we update what we have here inside the coordinate. Of course, we still don't have the base values for the row and the column, but we can get there from the square, like so. So square dot coordinates, we have the row and the column. These will be sent here. We have defaults of row and column, and now these coordinates, we can send it there, being of type coordinate model. It's simple. It's simple. It gives a bit more work because we need to make it very generic, but you see that the idea is that we can change the row, the column, up, down, make the for, and we break, we add the moves, and by the end of it, we return all the valid moves. We come back to our function here in our where we do the rook, and we need to specify here which ones are we going to use if we're going for the row or the column here. Say update row false, update column true. It's the column that we are updating. And this is the change for this for. Now this for is being done into here. We can replace this, copy paste basically, and for now this second one, column -1 and position being 0, increment of -1. Update row false, the row keeps the same, the column updates. With this, we remove these two here. This is move within row, and now we can do the same, as you can imagine, for columns. Right, already my lint put everything in a different place. Okay, everything it's online. What we have here then, start position being row +1, and here row -1. Increment and end positions, they're already correct, and we're going to update the row, but not the column. And with that, we remove these two fors. Did we reduce a lot the amount of lines we had? No, it's basically the same, but the logic, it's in one place. And now we have one function which can be used to create these valid moves. All the logic, it's inside in one place. And we basically didn't save because lint puts everything in a different line here. We could simplify it a bit if you let everything in the same line to be, of course, less lines, but that's not the most important. The amount of lines in the code is not the most important, it's how readable it is. Okay, let's save this, refresh our page here, and see if we can move our rooks. I'm going to remove here, change this one, go here, our other rook here. Seems fine to me. Put this one, can go up to there, cannot go back. Everything seems fine. Yeah, everything seems in place. And that's the movement for our rooks, but now refactored in a single function, which use the for with generic parameters, using break, and also checking for the pieces and everything. Everything we need. This is what we have for the rook.